Welcome to step 3. Last time we ended here where we created an API with Flask and we tested out the API and saw that we got some response back. Now the API that we have in Flask, we are going to create a Docker container that serves the API with gunicorn, and I will explain all these terms that you've heard newly. First of all, let's try to understand what is this Docker container. So previously, once I've built this, welcome to step 3. Last time we ended here where we created an API with Flask and we tested out the API and saw that we got some response back. Now the API that we have in Flask, we are going to create a Docker container that serves the API with gunicorn, and I will explain all these terms that you've heard newly. First of all, let's try to understand what is this Docker container. So previously, once I've built this and I gave someone else to run this API in a new server, what I would do is I would give all the Python scripts that I have. I would give a requirements.txt file, and if I have to do any installs, I would give a shell script to run in a Linux machine. So basically it used to be a bundle of scripts that a developer need to run or automatically scheduled to run through some other process, which will install, spin up a new let's say EC2 machine, and put all the required files in the required destinations, then install all the necessary things, and then run the server. Now if you see, there are a lot of moving parameters here, that is placing files in the right place, installing the right libraries necessary, and also making sure that the operating system is compatible with the libraries that you install, with the changes that you have done, and with all the files. Now we might encounter a lot of errors if, let's say, you move to a new EC2 machine, it might not have all the updates that are necessary, and during installation it might fail because of operating system incompatibility with some changed library or things like that. Now removing all these parameters, instead of giving just raw files and asking to run on a system, either a Linux system or Windows system, any of these, can you containerize it? What that means is, can you go one level up, create a container which is basically a Linux machine or Ubuntu machine or Windows machine. So assume a Linux machine. So you take a bare bones Linux machine, you install all the libraries that are necessary, you place all your files in the correct places, then you run the server, Flask server, it is up and running. Now if you give this container, there are no more other dependencies or incompatibilities that exist, since you have already packaged all the files in the necessary places and kept all the installed all the libraries and took care of operating system. So you give this packaged container that already has an operating system and all the files in the right place. So every time you run the Docker container, no matter where you run it, as long it has minimum resources of RAM and other things, it will run the same way. So there are no more inconsistencies and unknowns that are there. Hence, the idea of containerization became very popular, and Docker is one of the most popular containerization frameworks that are there. So essentially, you would create a Docker container, which in turn means you will create a Linux machine or Ubuntu machine that already has all the things in the right places as expected, and any developer who takes the Docker container, they just need to run it with one single command and it will always run in the same way. That is why Docker container became very widely popular. And now we are going to do the same thing, which is we had our Flask API and we are going to create a Docker container that will run the API with just one command, packaging everything together. So we will create a Docker container for our Flask API. One more small thing to remember is I mentioned the word gunicorn. So gunicorn is an app server. What that means is right now we are serving the API with Flask. Now Flask is not built for production use case. That means it's not meant to be run in production where you have several API requests coming in and you're serving them simultaneously. So we need another app server like gunicorn that will take care of spawning up multiple threads, and if you're getting a lot of API requests, load balancing those APIs between the spawned threads. So all of these. Load balancing simply means if you get 5 or 6 requests, instead of just one process handling all of those, how do you distribute them between the processes? So gunicorn is made for production use case. That means instead of Flask, we will we will use gunicorn on top of Flask to run as app server, and we will see how all of these things are done. Now last time we ended in this file where we created an API with Flask, and I just copied the same file into the folder called Docker deployment. Since we need few more additional files, I just created a new folder called Docker deployment, and I copied the same file, and now I'm calling it app.py because this is the final file that we will be running in the Docker environment and creating a Docker server. Hence I'm calling it app.py. So the only change that I made to app.py was this last line. Previously I used to have this app.run and the default port was probably 5000. Now I'm explicitly running it at port 80. So there are no other changes for this app.py file from the previous app_step_2. It is exactly the same with just one more change. So this is the final file that we will be using to create Docker container. Now we will go through all the 4 files that are here that are essential to create our Docker container. So we just looked at app.py. It is same as previous with just addition of port is equal to 80. Now we have this wsgi.py file. This is fixed template file from app, import app, and app.run. There are, no matter what you're running with gunicorn, you would use this. So this file is requirement from gunicorn, and this file content does not change. It is fixed. So assume that you have a fixed file called wsgi.py and just 2 lines. So we are done with app.py and wsgi.py. Now let's go to requirements.txt. So if you remember, why do we need this requirements.txt? Instead of always doing pip install x, pip install y, pip install z, instead of installing those via command line, if we can give all the libraries that are necessary in one file called requirements.txt, you can run that file from pip directly. Now when you create a Docker container, if you just give requirements.txt, it will be automatically run. We will see how that is done. Now going back to the libraries that are in here, if you remember, we did pip install spaCy 2.1.0 manually, so we are keeping that here. And we also did, when we were creating an API, we installed Flask and Flask course. We also need that. Now, since we are using gunicorn for app server, we also need gunicorn. So this is how requirements.txt file looks like. Now we are done with looking at 3 files. Let's go to the main Docker file. Now let's look at the Docker file. So the first line in the Docker file is what is the base image that we are using. So you can assume that the base image is kind of the base Ubuntu or Linux machine on which you have already configured something. So anyone can create, so let's say you want to use a Linux machine that already has TensorFlow installed. So you can use the above line from TensorFlow/TensorFlow 1.4.0, 1.14.0 Python 3. Then you go to build on top of that base image. I'm just using the base image of Python 3.6, but I just kept this line so that you can understand that anyone can create a base image and upload to Docker Hub, which is like GitHub for Docker containers. From that you can use that base image and create any other code on top of that. So I'm using just a machine that has Python with 3.6 installed. So I say from Python 3.6. Now it says what is your work directory. Work directory is basically, you need to create a directory in your machine and you copy all your files that you're going to run on there. So I'm just saying work directory /var/app. Automatically this directory is created. So copy dot space dot. What does this mean? This just means that we are going to copy all the files in the same folder as Docker file. That means app.py, docker, requirements.py, wsg.py. All these 4 files will be copied onto /var/app. That's what this does. Now, if you have like a big model file that's built on TensorFlow for like, if it's like 1 GB or 2 GB, still you can place that here and you can run the same command. It will copy that file as well onto the /var/app. Now, once you have copied all the files, you run pip install -r requirements.txt. See that we have created a file with requirements.txt, all the necessary libraries that are necessary for our code to be run. So we just run that. Then if you remember, we encountered an error with spaCy, that the spaCy English model is not loaded. So there we ran this command, run python python -m spaCy download en. So we are going to do the same thing and run this command. So base image, then directory, copy all the files to the directory, run all the necessary things, then expose your port 80, that is like the default port, and also we use the same port 80 here. Then this is like standard line for gunicorn that I told is the app server that runs this app.py file. So here one thing that you can play around with is workers. So this is workers per CPU. So if your CPU, if you have 4 CPU machine, there are 4 workers. Workers are like, you can assume 4 processes that are spun up. So we come to the end of this Docker file. Now we are going to copy this whole folder Docker deployment and then build our first Docker image and push it to Elastic Container Registry. Now we can look at how we can create a Docker image on our EC2 machine. So I'm logged in back into the same EC2 machine. So since I do not remember what my conda environment was, I can type in this command conda and list, and I see, okay, deploy DL production. So source activate deploy DL production. So I'm inside my conda environment. I'm in the same folder, production deployment. Now I will use WinSCP to transfer all the files onto my machine. Now if you see, I'm in the Docker folder, and you see all the 4 files that we have been dealing with so far. Now we are ready to create our Docker. So just type Docker to see the Docker is installed, so we can get some commands, help, etc. So Docker is installed by default on this EC2 machine. That's why we chose this machine specifically. Now the Docker is installed. So we can run docker build -t, give any name, spacey python, any name, and current folder dot. So if you see, it runs in steps. First it will download the base image that we gave from the line from Python 3.6. So it is currently pulling from Docker Hub, and then it will sequentially execute the steps that we have written in the Docker file. So this, if you see, the second line is what directly /var/app, and we are installing spacey. If you remember, we create this, copy all the files, run pip install requirements.txt, download spacey, and expose port 80 and run gmcall. So all these steps will be run. So we have successfully created our Docker image, as you can see. Now we are going to just type Docker images and see that we have spacey Python that we just created, and the total size is 1.5 GB. So this is the size of the Docker image that we created, 1.5 GB spacey Python. Now we will see if we are able to successfully run this Docker image. So we built the Docker image, which means the Docker image is created. Now we will just run the Docker image in this EC2 itself to see if it's functioning as expected. So you can do docker run port mapping 80. So we are mapping the port 80 of Docker to port 80 of this EC2 machine, and spacey _ Python. So that should be good. Docker run space for port, and you give the name of the Docker image that you want to run. So if we go to the EC2 console, you can copy and just paste and see that it is running. Since we are running on port 80 itself, we do not need :5000 or anything, since 80 is the default port. So you can see that it is automatically running here. And now I'll go to Postman. So instead of giving 5,000, I will just give the original URL and then get entities and click on send. So you can see that we are returned back the entities just like previously. Now one thing to remember is there is no output here. So if you are already confident that everything is working, you can do this way. Otherwise, what I would suggest is in your initial code, in the app.py, keep debug is equal to true. Now that Docker is created and it is working, we need to push the Docker onto either Docker Hub or Elastic Container Registry provided by Amazon. So almost like GitHub, where you push the code, you can push any Docker image that you have created, and Amazon provides ECR where you can push the Docker image that you have created. So I'm going to just navigate into Amazon ECR and click on get started. So production test, I'm just going to give a name to the repository, production test Docker. So it created a repository automatically, and there are no images currently because we haven't pushed anything. I am clicking on view push commands. So these are the commands that we need to run here, and we will be able to push the Docker image onto the registry. So right now it is asking to run this command on the EC2 machine that we have. So let me try to run this. So it says unable to find credentials. So basically first I need to configure my AWS credentials on this machine so that it has access to push to ECR, Elastic Container Registry. Now I just created some credentials on here by adding a user on IAM console, identity and management. Make sure that the user that you create has access to ECR and EC2 so that he or she is able to push to ECR. So let's go ahead and do AWS configure. So AWS configure, it asks for access ID key. Secret key. Default region name, US East 2, because I am in the Ohio region. Default format none. Now I'm going to run the same command that I ran above. So login succeeded. Great. So this first part is done. We have already created our Docker image, so we don't need to do much. Now After the build completes, tag your image so that you can push the image to this repository. Great. So take this command. Remember here they have used build test docker, whereas the name that we used is Spacey Python. So I'm going to do docker tag instead of this, use Spacey Python. Latest, and this will remain the same because this is what we created on ECR. So the tagging part is also done. Let's go back and run the final command, docker push. So docker push, so no need to change any of this because we have tagged it with the same name. Once you do docker push, it is going to push our image onto AWS Elastic Container Registry, ECR. So everything is finished. Now let's go back to ECR and click on the repository that you created. Previously there was nothing under these images, whereas right now if you just refresh, there is an image that you just pushed to Docker, pushed to ECR from our EC2 machine. So you are able to see that. This concludes step 3, where from the API that we had through Flask, we were able to create a Docker image and provide an API with gUnicorn, and then we were able to push the Docker image onto the AWS ECR. Now in the next step, that is the last and final step, we will see how we can use Elastic Beanstalk to run this Docker image in a scalable manner.